All right, everybody. So on this one, we're going to figure out where the electric field lines are and where the equipotential lines are, which we talked about in class already. And so what does that mean? So we've got this hooked up. This is the way it'll look when you hook it up to the Pasco. We've got the voltage detector here, and we're using the Pasco to actually supply the voltage for the system. And so I'll show you how to set that up in just a second. But we'll have this black conductive paper. You'll have two tacks that you'll put into the paper, and then we'll map the field lines accordingly onto the paper itself with some chalk, which I don't have for this video, so I'm just going to use a pencil. All right, so what do we need to do? We need to start the capstone program. Okay, and now we have the capstone I'll remind me later. We have the capstone program up. Now we need to go to the hardware setup and make sure that we have the sensor, and I can see right there in port A, the sensor's already there. And we have the sensor plugged in here, so that's good. So we can get out of that. Let's go to data, and we see that it shows voltage, which is what we wanted to measure. That's great. So that's good. Now we need to go to the signal generator, which is straight down from there. And we have the signal generator. Okay. So we don't want a sine wave. We want this to be like a solid DC current, or in other words, it is just like a point charge. It has a charge and it's not changing. It's just straight up that charge. So we need to go here, and to mimic that, we're going to click on DC. That's a steady voltage applied to this system. Nothing's changing. And the voltage we want to use for this is 5 volts. And the voltage limit, we don't want to go over 5 volts, so we'll leave that at 5 volts as well. And we want to set this to auto here, and we set this to auto because we want it to start recording when we press record. So kind of redundant, but you'll see what I mean in a minute. All right, so that's all set up now and looks good. So let's get out of there. Let's go down here to the bottom, and let's set the sample rate at 10 hertz. So 10 times per second, it'll do some measurements. It's quite a bit. Now, how are we going to see this? What are we going to see when we do this? So we need to come over here, and you'll find on the very right-hand side, you'll see this one that's called digits. And so if you click on digits, double-click on digits, it'll bring up this box here. Now, it may have 1 or 2 or 3 places here. And so you can come up here and change that in just a second. So I'm going to say measurements. We want voltage. So it's got 3 places. We don't really need 3 places. So let's go up here to the top left-hand corner, and you'll see that there's like this one with the red arrow. All that's going to do is take away one of those places. So click on that, and so now you have this set up just like this, so that you now have 2 places showing. It's measuring in voltage. And so now what do we got to do? So we've got everything all ready to go. We've set up our detector, we've set up our waveform, we've set up the box over here. We have the red connected to the red and the black to the black, or positive and negative. We have the voltage detector to channel A up there. And so now all we got to do is we've hooked up the positive to one side and the black to the other side, and we just kind of put it on these metal tacks that I've stuck into the paper. And so now we should be able to see a voltage change as we go from one end to the other. So we'll start the record now. There we go. And so we have basically no voltage. It's probably reading me. I'm going to put that there, and we have 5 volts, which is what stay on there, which is what we want. 4.99 volts is close. Okay, so as we go from there to here, we should see that potential go down. And so let's go every two the pluses on the paper here. These pluses act as 1 centimeter. So let's go every 2 centimeters and see what happens. So if we go 2 centimeters away and we put it down quickly, we have 3.22. Go 2 more centimeters, 2.78. If we go another 2, 2.29. If we go all the way to the end, this should be 0. So there you go. That's the first set of data that you're going to have to put into. So what we need to do now is we're going to find the equipotential lines. And what does that mean? So that means at some distance away, if you remember from class, at some distance away, that R, right, Q1, Q2 over R squared, is going to be some distance, or some voltage at that distance should remain the same. And now we have a dipole system here, though, so we should be able to figure out where those equipotential lines are and what they look like. And so, excuse me. And so we can start off, we know that we can go through here, so let's just go 1, 2, 3, 4. Let's go 4, and that's 1.61. So at 4, we have 1.61. So where else do we have 1.61? So let's start looking around. Basically right there we have 1.61, so I'm going to put a mark. And over here somewhere, we have 1.61. And then over here, somewhere we have 1.61. So you'll have a chalk pencil, and so then you can actually draw this line in to figure that out. And then let's go to the middle here and see what this one is. This is 2.23. So right there in the center is 2.23, and let's go around and see what else we can find. 2.23 is right there. And so you can draw those in with the chalk. So now we can draw that in, we can draw them all the way across. So now we got to figure out the last part. Is we figured out the voltage drop across here. We figured out where the equipotential lines are. And so now we really want to just map these electric field lines. We're just going to use these 2 probes that we've been using. I'm going to put them like that so that we maintain this distance apart. And you got to be careful when you're doing this. So when you set the black one down on a spot, make sure as you're rolling it round, maybe I should do this with the other hand. As you're moving it around, make sure that you don't, that it doesn't move, right? So because you want to find the highest spot. So we have, everything is still remain the same, so let's try and map out these field lines. So I would start maybe like here, and then I'll put the red down, and you can see now that we have 40 volts, and if I start going to the 41, if I keep going, I'm back to 40, 39, so I've gone that way, and it's gone down. So now I come back this way, 38, 37, so it's gone down. So I would find that high spot, 40, 41 again, and then I would draw a chalk arrow between there. Then I'll move it to another point, maybe like this one, and I would do the same thing again. And I would roll it around, 34, 33, 32, 34, so there I would draw my chalk arrow between the 2 of those. And then I would do it again and again and again, and I would just follow on wherever the tip of that last arrow that I just drew, I'll stay there and I'll keep going across, using the tip of that arrow all the way along. Right? And so then you can see you're starting to draw this line based on that arrow to the next arrow to the next arrow to the next arrow, and you'll find that that'll go over there and connect with the other one. And so then you just map those field lines out. You map the equipotential lines out like we said, right? So you find the voltage that's equal all the way across. And then I'll have on this side, I'll have a stripe across here that's a conductive material like silver paint. And so it'll come across there and it'll come across there. And then you'll do this exact same thing again over here, but you'll map the field lines and equipotential lines, and you'll notice that this acts like a parallel plate electrodes, which are the field line distribution and the equipotential lines will be different. Like we talked about in class, you'll see that it's a homogeneous field through there, or it's more homogeneous, than this side. So with that being said, I think you can manage everything now and you get the gist of it. And so I'll see you in class.